Okay, here is a quick screencast about no fun, get back to one. It relates to fractions. Been doing a lot of fractions posts and video, so this is a actual tutoring session with an autistic child, and I forgot to get the camera out until we got to fractions. We were doing all kinds of other stuff, multiplication and multiplication with larger numbers, square numbers, building tens, did add-ins. Anyway, then we started playing around with fractions. So here, I played a little game. We played with some other pieces, but here, like I said, finally started taking some shots. This is now 1. This 4 right here. So if this is 1, what's this one called? And for her, it took quite a while for her to figure out, and I just sat there, waited patiently while she figured it out, that this would be 1/4. It would be 1 out of 4. If this is 1, this is no longer a 1, this is 1 out of 4. So we did a little 3-period lesson and played with pieces and fooled around with, okay, now I pull out another one, and she tells me what she thinks it is, and I always tell her something different until she understands that she has to know what 1 is before she can tell me what this is. Because this could be a half, or it could be a fifth, or it could be an eighth, as you'll see in a minute, or 9th. So we have to know what the 1 is. So using my imagination, this is now a 1. And see, my 1 is broken into 4 parts. So if I have this many and 1 more, what do I have there? I have 5/4, which would be 1 and 1/4. Okay, and that's the way we started out the lesson. If I call this anything I want, what's this then? Okay. Now, once we get that under our belts, we can fool around and say, okay, see, that should have been the first picture. Anyway, this is a quarter, if this is 1, right? So now, if I know that this is 1/4, give me 19 quarters, please. So she gets 19 quarters, 1, 2, 3, 4, that's 16, and 3 more, right? And so she counted out 19 quarters, and then I said, okay, well, how many 1s is that? Because each time I get a 4, each time I get 4 of these guys together, that's 1, right? And she was able to tell me how many it was. Oh, and by the way, the reason why we're making long, like this was the beanstalk and so forth, and okay, because it's fun, right? Why don't we have them in a rectangle and put them sideways and close together? Because this is more fun, and she wanted to build them that way. So why not let her build them that way? Okay, so then, once we got that down, and we're going to go from the bottom to the top, we start with this problem and then move our way up. 29/4. Right? Bigger is just funner, right? Makes a longer line. What's 29/4 look like? Or if I was counting out 1s, how many would that be? And I think I left the picture off. And then what if we went back to the 3s? Now this is 3, so this would be 1/3. What if I had 19/3? Can you get out 19/3? And there's 19/3. Right? 3, 6, 9, 12, 15, 18, 19, built with 3s, right? So this one tells me what 1 is. So she could see very easily that that's the same thing as 6. There they are, 1, 2, 3, 4, 5, 6. And any little kid can do this. And 1/3. Fractions, easy, fun. It's just counting. And so then it starts getting longer and longer. We got 29/3. And she could see that 29/3 is the same thing as 9 2/3. And now we change it to fifths. What if we had fifths? We did 3, 4. Well, what if this is a 5, then this is 1/5. And this is 5/6. Or excuse me, 6/5. So now, get me out 28 of them. 28/5. Well, that's going to be fast and easy, isn't it? Because all I need is 5 5s and 3 more. Right? And there, it's because it was starting to get too long, we made a square, and there's 3 more of them. So we count out 1, 2, 3, 4, 5. Right? Now they can start seeing the division and what it means when you say get as many 5s out of that 28 as you can, and that this can definitely mean as an improper fraction 5 is contained in 28. It can be a relationship. For every 28 over here I have 5, but here we're turning it into a discrete number, 5 3/5. So now we start working on these other ones. So these pictures are out of order. I've loaded up into my display thing oddly. Okay, so anyway, there's 29/4. We did that one. And now we can do any of them, right? Now we can do 36/7. That's easy, right? They're all easy. Once you do a few of them, as fast as I can put them up there is as fast as you can sum them. And it was pretty, like I said, we would make it, why is it all in a long straight line? Because it's fun to just make it a long line like that. But we ran out of room because 9s wouldn't go all the way across, so this one we built this way. And now, notice on the last one, we take the next step, right? Where we have to reduce the final fraction. And I've been avoiding that the whole time on purpose, right? You didn't see any 2/4 or 3/6 or anything like that. We made them so that they came out to be fractions that didn't need reducing. And now we have a fraction that does need reducing, right? 59/4 is the same thing as 5 and 6/9. What's 6/9 the same as? That threw her for a loop. Took her quite a while to sit there and think about it. And I just sat there and I say, well, can we take a look? And right, don't need to use terms for little kids about common factors and all this other stuff. If I have 6 here and 9 there, can I reduce it, or can I see a relationship? Can I see a number that will divide evenly into both of these? Right, the common factor. Well, here she sees, oh, well, there's 2 3s there, that's 6, and 3 3s there, that's 9. And there it is, labeled out. And then I wrote down 3 is the common factor, just for fun. Mostly for you guys watching, not so much for her, because she could care less what a common factor is. But later on, as she hears it and sees it in use and so forth, she'll know what a common factor is. But it's not a fact that I give to her to memorize, or here's a math term for you to know. But this probably took 5 minutes or so of her thinking and noodling around for her to figure out that 6/9 could be turned into 2/3, even though we've done this before. Alright, so now let's move on to a very simple concept. I've done this before. You'll see I have a full motion video on this, but let's cover the same lesson, right? And look at all the stuff we've covered here. That was a few minutes on fractions. We did add-ins before that, as you can see from the tray there. We had fooled around practicing multiplication, and now we're just doing fractions. So here, 2 times what is the same thing as 6? 2x equals 6. So there's this, right? We built it. And she goes, oh, that's really easy. That's just 3. Right? Because 2 times 3 is 6. I said, well, that's great. So if it's that easy, what about 2 times what is 5/9? Master, is that any fun? And she kind of wanted to say yes because she wants to say that math is fun and so forth, but actually that's no fun. She agreed that, yeah, that doesn't look like any fun at all. So, alright. Well, why not? Well, because it's hard to figure out what's going on over here and what to do and divide 5/9 into 2. Well, Uncle says, alright, let's think some more. What do I have to multiply 2 by to get 1? And so here's a little picture of it. Here 2, right? These 2 units, what would I have to take out of each one of them or multiply them by to get 1? Can you see that if I took a half out of this one and a half out of this one, right? 2 times a half would give me 1. And these 2 are just there to show that these are drawings that represent blocks, but since they're so small, we made them bigger so we could fool around with them and see. And she could see that, yeah, if I took a half of that one and a half of that one, I get 1. So 2 times a half is the same thing as 1. Okay, now we're starting to learn where that came from in the very beginning, the no fun get back to 1. Oh, so now, here is 1. See, look, 2 times a half is 1. Right? This times that, there's my 1. Okay, so then what times 5/9 is always going to be 5/9? 1, right? So now that I've got this 1, what do I have to multiply 1 by to get 5/9? Well, that's easy, right? 5/9. 1 times 5/9 is 5/9. Alright, so now we just do the math. And she thought this was the coolest thing ever. And you get, just straight across multiplication, 5/18. And she could see that x is the same thing as 5/18. Alright, now once we did one of them on this one, it really clicked. Because as soon as I wrote this problem down, bam, she wrote down the next problem. Right? So I have 3 times a third. That gave me the 1. Right? And I said, can we do any of these now? And she goes, yeah, I think so. So now that I have 1, what times, what do I have to multiply 4/11 by, or excuse me, what do I have to buy 1 by to get 4/11? Well, 4/11. Right? It's redundant and simple. So she took seriously about 2 seconds to sit down and write this out, and then she looked at that for a minute because she wasn't 100% sure what 3 times 11 was, because she was having a mental lapse there. But then after a second she got the 33, and she could see that x was the same thing as 4/33. Now some of your students, being very clever, will be able to see a rule here, but I'm never going to tell them the rule. Do you see what happens here? The 3, oh. And now they understand why that is, right? It's not just some invert and multiply thing where I take, okay, we're fooling around with 1, the concept of 1. So then I gave her 2 more, right? So here are, what's 4x equal to, 4 times what is the same as 7/8? And there she is trying to figure it out, not having enough space left for herself. But see, she's making a 1. The first thing she knows is to make a 1 now to solve these. And there it is. There they are, both worked out. And she worked through both of these problems in 60 seconds or less. I mean, seriously, as fast as I put them there, it took her just as fast to write them down. Right? And she made a couple, had to make some room for herself, but there you go. So you can see the answers are correct, and it's fast and easy and fun when you know what you're doing, because math is fun. It is. Learning is fun when you can do it. It's not hard, and you're not just following the process, but you can actually conceptualize and see what it is you're doing. And soon we're going to come with Hero Zero. We're going to cover what it means. What does Hero Zero mean? You'll see this in one of the problem-solving videos, but I mean, Hero Zero can come in handy when you're doing algebra, when you're factoring problems that have negative coefficients. Hero Zero is great. He comes in all over the place, and he's impervious to multiplication and division, and anything he multiplies becomes 0. But anyway, those 2 concepts, Hero Zero and No Fun Get Back to 1, understanding those 2 things, plus the other 3 concepts out of the 5 concepts, you can do all the mathematics. Really, all of the mathematics will be available to you if you understand No Fun Get Back to 1 and Hero Zero. Problem solving will help you in the pre-calculus, it'll help you in calculus, it'll help you in all areas of your mathematical endeavors. Anyway, Crewton Ramone's houseofmath.com for more.